So, interpreting the results. We have two different statistics here. We have the Ryan-Joyner test statistic, and higher values correspond to a higher correlation with expected normal distribution. So that means that a higher Ryan-Joyner test statistic shows less deviation from normality, less non-normality. The Ryan-Joyner critical value is RC, and with smaller samples, they lead to a lower critical value, allowing for more deviation from the expected normal distribution. So as your sample sizes get larger, you have less deviation from the normal. Okay, so if your RP, your correlation, is greater than your RC, then we can assume normality, because our correlation is higher than the minimum acceptable. That's really what your critical value is. It's your minimum acceptable. Now, if your RP is less than your critical, we cannot assume normality. Again, going back to that initial statement, how much is the non-normality going to hurt? RC is the level where you no longer allow it. So that's when it hurts too much. So if you are above that hurts too much, then we're going to say, yep, we're okay, we can use it. If we're below that critical value, we say, ooh, the non-normality is, it hurts too much to assume normality. So let's take a look at an example. Let's say we have n equals 30 samples. So that gives us a critical value of 0.96389. Let's say we have an RP value of 0.98615. Because 0.98615 is greater than 0.96389, so RP is greater than RC, we can assume the data follow a normal distribution. Let's look at another example. So we're going to assume we have the same RP, but now we have 100 samples. That gives us a critical value of 0.98744. As we see, with higher number of samples, we have a higher critical value, which means that we can deviate less from normality without it hurting. So, in this case, 0.98615, the same RP as before, is less than our new critical, 0.98744. Therefore, we cannot assume that the data follow the normal distribution.